Hello and welcome to your first video lecture for Chemistry 121. I just wanted to go through a few kind of note-taking things before we jump into scientific notation. I have a few kind of tricks, little things to do to make your notes much more usable and user-friendly so that you can go back and actually use your notes that you take to your advantage. I find that a lot of students, they take notes, but they never actually go back and use them. And if they do go back and use them, they're so unorganized or they haven't looked at them in a while that they just lead to mass confusion. So a couple tricks that I use is you'll notice, well, for one thing, whenever I have a video up on YouTube, pretty much it's going to be a lecture of me talking and writing out the notes with you. So for the most part, we'll start with just a blank page and I'll write the notes out with you. There are a couple times where I have kind of fill in the blank type notes, and those files will be available to you on Moodle so that you can print them off and fill them in as we go along together. Another trick that I use is I use multiple colors of pens. I have quite a few different colors of pens, but for today I'm basically going to kind of stick to probably three colors, the black, blue, and green. On occasion I might use the red. Then I also use one final color. I usually choose some obnoxiously bright color. In this case I have a hot pink. I reserve this pen for, starring things or boxing things that are particularly important, things that you'll need to memorize, that you'll need to know for any exam coming up. A highlighter works really well for your own notes if you want to follow along with my color scheme. Some other things, if I use any images from your book or any images in general, for example, for Chapter 1 I have a number of different images that I'll use, I will make these available to you on Moodle so you can print them out, cut them out, and add them to your notes if you would like. All right. Some other kind of organization tips that I use for writing notes is I always reserve about the first, half inch or so, depending on how big your writing is. I'll just draw a line all the way across and I reserve this as a heading. And I use this space to kind of fill in after I've taken my notes to tell me what's on that page, how far into my notes I am. Basically just kind of a header to make things easier to find in your notes. So if this were, say, after I've taken notes, I would probably go up and say, this is Chapter 1. I would probably include what section number basically the notes started at so I can flip through and easily find things. Another thing that I include is I include the page number of my notes, and that's kind of just a nice thing to see if you use loose leaf paper. In case they get out of order, it's easy to put them back in order. Another thing that I use this space up here is I'll put the date that we covered that material or the date that I took those notes. Now on this online course, you're going to be covering notes, covering these lecture videos on your own time. So dates might not be as helpful in this case, but for other classes that you might take that aren't online, it's helpful to put the date that you took those notes just for communication's sake. If a friend in the class comes up and asks, hey, I missed, Tuesday the 5th, what notes did we take? If you use this and you fill in what dates, it's really easy to find where in those notes your partner needs to take over and start writing notes. It's just a really easy thing to do to make your notes much more navigation friendly. Another thing that I do once I start taking my notes is I always include my headings. So in this case we have scientific notation is what we're covering. And since these lectures are going to be very section based, I am going to include the section numbers. Some classes, they don't follow the book directly, so the section numbers might not be mean as much. I, however, will be covering the book section by section, essentially. So I will include those section numbers so it's easy to correlate where this information is found in your textbook. Another really simple tool to use is what's called a straight line all the way across your paper. I use this a lot to kind of signify that that topic has been done, it's complete, and we are ready to move on to the next one. It's just kind of a visual clue when you're flipping through your notes to see where a topic has ended and where a new one is going to begin. So let's go ahead and jump in to our scientific notation discussion. Many of you may already know scientific notation. If that's the case, feel free to skip on and maybe practice a few questions and problems in your book just to make sure you have it down. For those of you who haven't seen it before, this will serve as a very good lesson for you. So let's go ahead and write down our definition. I typically put vocab words in a different color so that they stand out a little bit more. Basically, standard or scientific notation is a way to express really, really big numbers and really, really small numbers in a much more concise way. So maybe an example of this would be the circumference of the Earth. Size of the Earth, we have 400,72665 meters. Unit of length. That's a fairly big number. It has a lot of digits to keep track of that we would have to, if we were doing a calculation with this, we'd have to write that number down, quite a few times. Gets tiresome. It gets, repetitive of trying to make sure you have all the digits written down correctly, entering it in your calculator. So instead, in science, we use this scientific notation, and we're basically going to express this number in a more concise way. Okay? The way that we do that is we find where our decimal's at, which in this case it's not written, but it's to the right of that 5. That's our ones place. And we're going to move this decimal place over to the left so that it's to the right of our first non-zero digit. And we're going to count how many times we move that. Now you can just do that by counting digits. I like to actually draw it on the paper. I make less mistakes that way. So I just kind of do little wave marks to count how many times I move it. So I have 1, 2, 3, 4, 5, 6, 7. And so I'm going to move that decimal 7 times. To write this now in scientific notation, I'm now going to write my new value here. I have my 4 and my decimal point, just so that it looks a little bit more standard of what you're used to. I'm going to include that 0 as the first value. In the next video, when we talk about significant figures, I'll explain when and why you have to include that 0 or when you do not include that 0. And so stay tuned on that. So we have our first part here, we have our 4.0. Then part of scientific notation is everything has this times 10 in it. And then we're going to have an exponent here, and the value of the exponent is how many times we move that decimal. So in this case, we moved it 7 times. So we're going to have 4.0 times 10 to the 7, and then we put our units at the end of that entire expression. So now we've taken our really, really big number, we've condensed it down so that it's easier for us to deal with. Now, for those of you who are wondering, hey, what happened to all these other digits here? Why aren't those important? Again, stay tuned for the next video on significant figures. All right, let's look at a really small number. So we have the size of an atom. I'm getting down into some chemistry now. Size of an atom is 0.00000000001 meter. Whew, that's a lot of zeros to keep track of. Much more convenient for us to write this in scientific notation. So our process is the same. We're going to find our decimal. Decimal's right there. We're going to move that decimal so that it's to the right of our first non-zero digit. So we want to move it all the way to the right of our 1. And again, we count how many times we move it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I move it 10 times. So my number now in scientific notation, okay, I now have this new 1.0. Again, stick to the next video to see whether or not that 0 is significant or not. So we have 1.0, we're going to have times 10, and we have our exponent here of 10, but we want to show that this number is a small number. Whenever a number is very small, that exponent is to the negative power. So we have 1.0 times 10 to the negative 10. And again, our units go at the end of our value. All right. Let's have you try some examples on your own. Try writing these, the following numbers in scientific notation. So go ahead and pause the video, try these out on your own, try working through them, and then if you get stuck or once you have your answers, go ahead and unpause and I will show you the answers. All right, so here's our explanation. We have our first value here. We're going to find our decimal. We're going to move it to the left. We're wanting to put it in between the 1 and the 8. We're going to move this 1, 2, 3, 4, 5, 6, 7, 8 times. So we have 1.8 times 10 to the 8, and we put our units at the end. Same thing here, we find our decimal. We're going to move it to the right of our 6. So we're going to move it 1, 2, 3, 4, 5 times. So we have our 6 times 10, and we moved it 5 times, but this number is a small one, so we want the negative value, and we put our units on the end. So we have 6.0 times 10 to the negative 5 meters. Third example here, we just move it once to the right. We have 1.5 times 10 to the negative 1 seconds. The fourth example, we're going to move it to the left 3 times for 1.5 times 10 to the 3. And our units here are the meters cubed. So we keep that together. This 3 here has nothing to do with the 3 from our 10. This just represents our numerical value here. Excellent. Let's do one more example. Now instead of writing in scientific notation, let's do the opposite and write in standard notation. So again, go ahead and pause the video, write these values out, and when you have your answers or get stuck, go ahead and unpause the video and I will show you the solutions. All right, so we're going to take our first value here. I'm going to write the first portion of it, and we want to move our decimal 5 times. Since this number is a negative 5, we want to make this number smaller, so we're going to move our decimal to the left. So we're going to take our decimal here, move it 1, 2, 3, 4, 5, and wherever we have a blank little wave, we're just going to fill that in with a 0. So I would rewrite this to be 0.000036, and then my units go on the end of the value. And so we'd have 0.000036 centimeters cubed. Now in science and in chemistry, it is standard to include the 0 out in front of the decimal. That establishes where this decimal is, and it's just common practice to include the 0 out in front. Now it's not technically incorrect if you leave that 0 off, but again, it is just kind of the standard way of how we write numbers in chemistry. For the second example, again, I'm going to start by writing that first value out. I'm going to move my decimal 4 times, and because this is a positive value, I want to make this one bigger. So I'm going to move it to the right. So I move 1, 2, 3, 4. So I'm going to add 2 zeros onto the end. So I have 87500, and my units of kilograms go on the end. For the third example, our decimal again is to the right of that 3. We're going to move it 2 times to the left because we want to make the number smaller. So we go 1, 2, add our 0. So we have 0.03 liters. For our last example, we want to move our decimal 5 times. It's a positive 5, so we want to make our number bigger. So we want to move our decimal to the right. So we go 1, 2, 3, 4, 5. We end up adding 3 zeros. So we have 212,000, and our units go on the end. So we have 212,000 millimeters. This concludes the video on scientific notation. If you need more help, need more questions, go ahead and review the Sapling Online questions. There's also some Q&P in your book to try. And the next video for this section, I'll show you how to enter scientific numbers into your calculator and how to read them as well.